Okay, welcome to the introduction or preface to the Wired CPU tutorial series. Yeah, I'm actually freaking doing it. I've been procrastinating on this a while. I've been meaning to do it, but I just never really got around to it. And school's starting soon for me, so I need to get this finished. If I'm ever going to do it, I need to do it now. What else do I need to say? A few things. This is not going to be edited. Like all my other stuff. If you've ever watched my other videos, I don't edit my things because I'm lazy and have other things to do. I'm so lazy. But yeah, this is going to be very off the cuff, just rambly. I'm gonna stutter a lot like that. I apologize in advance. But what else do we need to say? I've already forgotten. Oh yeah, this is the preface part. I'm gonna put timestamps in the description of the video. If you want to skip this preface, just go ahead to the description and skip to the actual coding part where I show you how to set up the CPU and everything. And yeah, what else do we need to say? I'm probably gonna do several takes of this. Oh well. What are we gonna be doing in this series? I have no idea what we're gonna be doing in this series. I'll see how this goes. This is a new thing for me. I've done tutorials before, but I've never done them in this format. I'm usually actually instructing people that by actually talking to them. I've never done it in this format, so this will be a new thing for me, and I'd like to hear feedback and suggestions of how to improve things. And yeah, I'm looking forward to seeing comments and things. Maybe I'll start a Discord as well. Just so I can discuss, creations you guys have made and things, and maybe I'll even answer questions, just maybe. But that'll be later. So okay, I think that's everything. I've probably forgotten something, but let's get started. I want to say, oh wait, no, there's one more thing. The CPU, the Wire CPU uses assembly. The assembly programming language, x86 assembly, at least a sort of basic version of it. So this tutorial series is going to be for people who have never done assembly before. Assembly programmers, I'm going to say a lot of things that you probably guessed or you already know just from me saying that, oh hey, this uses assembly. So this isn't really for you. You can still watch, but you probably really don't need a tutorial series, to be perfectly honest. Is there anything else I need to say? I think that's it. Alright, let's get started. Today, what will we be doing in this video specifically? I will be showing you how to wire the CPU up to things like a wire screen to show numbers. I would do the traditional hello world example, but that's kind of complicated. I'll probably do that in the next video if I ever do that. It just requires a few more things and concepts for you to know to actually do the classic hello world example. It's not simple like C++ or anything, or E2. I have no idea how to do an E2 because that's not my thing. But yeah, let's get started. I'll be explaining things as we go. Like I said, I haven't done any of this beforehand. The code will be written on the fly simply because I believe a good tutorial should show you how to do things correctly and how to do things incorrectly, just to show you how to fix things. And since I do things wrong a lot, I'll probably run into some problems, and I'll show you how to fix them, because if you need this tutorial series, you're probably going to do things wrong, and I think it's important to show you how to fix them in this video. So that's bad. Ignore that. Maybe in the future I'll do code reviews and explaining how I do things. That's the hello world example. That is why I'm not doing it in this first video. You need to learn some other things before we do that. Before I wire the before I start coding the CPU, I need to place it. So go to the wire tab. It's in the chips and gates folder, the CPU right there. For memory model, if it's not on the 64K RAM and ROM, just select that and select whatever CPU model you want. Doesn't matter, and then just place it somewhere like that. Simple enough. Okay, so I should probably explain the inputs now. There are several inputs, as you can see. There's the memory bus, the IO bus, the frequency, CLK, which I think stands for clock. I might be completely wrong on that. Either way, I'll tell you what it means in a second. There's the reset, switch, and the interrupt. Today I'll be going over IO bus frequency, CLK or CIK, I'm not actually sure, and reset, because the other things are a little bit more advanced and you won't need them for this video. Okay. IO bus. IO bus is for sending out just generic normal numbers via something called a data port. You can just search it up here in the Wire search bar. I don't actually remember where it is. It's down here somewhere. I just don't feel like looking for it. I have all this stuff favorited. It's probably a good idea to do that. But via this tool called the data port, place it on here like so, you can send numbers out to other devices that aren't specifically made to use the CPU. You wire it like so. Select this, then select any port. Oh yeah, you can select any port, like 4, port 0, port 4, port, I don't know, 7. It doesn't matter. It doesn't matter which one you choose. It'll still work the same. I'll show you how to actually send numbers out once we get to the coding section. Frequency is the speed of the CPU. You set it to something obscenely high, like I don't know, 60,000. It'll run faster than it runs by default. I think the default value is somewhere like 4,000, 1,000. I can't really remember, but yeah, it's the speed of the CPU, and you can set it like so. Frequency, and then just pick a number, and it will now run at that frequency. The next thing we need a wire button, and specifically it needs to be a toggle button, and then just place it like so. And then this is the CLK or clock or whatever you want to call it, acts as the on and off switch for the CPU. You send it a value of 1, the CPU will turn on and it will start running. If it's 0, the CPU will not run. Simple enough. You wire it like so. What else? We need another button, a normal button. This button should not be toggle. Just place it down normally. This is required for the reset switch, and well, here we go. You wire reset to here. Now the reset, what it does, if you send a value of I think 1 to the reset, it resets the CPU state essentially. It restarts it, and it goes back to the top of the program, and it gets a copy of the code from the ROM. See, RAM/ROM, there's ROM as well, read-only memory, and it reflashes essentially, or I don't know if that's the right word, but simple enough. It's the reset switch. You should know what a reset switch does. And is there anything else I should go over? Oh yeah, for this little tutorial you probably need a wire screen. We're just going to be sending a value or some numbers to this wire screen. It's in visual screens and just a normal screen. The text doesn't matter. Call it whatever you want. I will be just putting it right here. Actually, let's change it just to make things look a little bit neater. Port 0 CPU. I will be wiring the screen to port 0 of this data port or of the IO bus. So select port 0. Actually, wait. No. Select A on the screen and then select port 0. I know what I'm doing. I think that's it. I'm pretty sure that's it. We can get to the actual code. Now there are some things I probably should explain. I should explain how this works, because it's very different from things like E2 or higher level languages and stuff, because like I said, it is assembly. It's very different. It's this alien beast compared to other languages. So right, programs run from top to bottom, of course, like in normal programming languages. There's nothing different from there, or there's nothing strange about that. In assembly, we have these things called registers. They're built into the CPU. They're like hardware things, you know. You cannot make new registers. They hold numbers, is essentially what they do. Different registers can be designed for different tasks. Like there's a few normal registers that you can use for pretty much anything. They're called general purpose registers. I will call them that from here on. So there's EAX, EBX, ECX, EDX, and those are the four basic ones. There's also the sort. What is this stand for? The source index. Oh no, whatever. It doesn't matter what they stand for. That's irrelevant. Either way, ESI and EDI, they're used for a specific thing, but they are also, I consider them general purpose. They're very useful. I won't be, well, I might show how to use that later in the tutorial. We'll see. So EAX, EBX, ECX, EDX. How do you actually move numbers to them? Simple enough. There's this there's the very basic instruction called move, M-O-V, the move instruction. So what this move instruction does is it copies data. It copies data from the destination, which is the you know, it's kind of weird. I know it's called a move, but it copies data. Don't let that confuse you. Like it will get you if you forget about it. So what is its syntax? Well, all right, here we go. So if you want to move or copy 1 to EAX, you do this. It's kind of strange in how you have to have the destination as the first operand or parameter, and the second operand is the source. So it's not the other way around. So you have to just be sure to remember that. That will definitely get you if you forget about it. So what this does, and this will run, by the way, this will run 3 bytes. It'll run. You won't see anything because I haven't sent the actual number to the screen yet, but that runs now. That works. EAX is now 1. You can move, you can copy data between registers as well. So if you want to do move EAX, EBX, that'll totally work. That will work fine. You're copying, this operation copies the data from EBX to EAX. I would explain the bit width and everything, but like how wide the registers are supposedly, because in real assembly registers have a certain width. So, you know, like they're 8-bit registers, 16-bit registers, 32-bit ones, 64-bit ones, 128-bit ones, etc., etc., etc. However, I'm not sure if that really matters with the Z CPU. Like I said, I'm not the best with this. I'm not gonna mess with those until I experiment more and confirm things. I mean, there are bit instructions, like you can do bitwise operations and stuff, so I'm assuming it works like it does in real assembly, but I'm not entirely sure. I'm not entirely sure how wide these registers are. The only reason I'm not sure how wide they are is because there's a distinct lack of the other registers. Like EAX in real assembly is a general purpose 32-bit register specifically, and then there's AX is the 16-bit variants, and then AL is, oh crap, wait a second. There's AH, which is, there's AH, and then there's AL. So like I'm pretty sure, what is it, the low bits of the AX register and then the high bits of the AX register, and those aren't a thing with the Z CPU, which is why I'm not explaining it. I'm not like, holy crap, this tutorial is so terrible. But yeah, you know, that's not important to you. You just want to know how to like send a number, right? So how are we gonna send a number here? That's pretty simple. All you have to do is, well, actually, there's an instruction specifically built to use the ports, or 2 instructions actually. There's in and there's out. So they do exactly what you think they do. In, like, takes a number from the port and puts it into a variable or a register or whatever you really want. Out sends a number to the port. So let's say if you want to do out, what is it, 1 EAX, actually it should be port 0. It sends the value EAX to port 0. So if you set EAX to 1 beforehand, it should send the value of 1 to port 0. Exactly. See, that actually works. Yeah, that's how that works. I would show you how to do in, Actually, you know what? Screw it. Let's show you how to do in as well. Like I said, this is very just rambly, just random. I just want to show you the very basics. Very basic thing here. Let's, actually, you know what? I'm going to wire port 0 to, sure. So now if you do in, instead of copying 1 to EAX, if you do in EAX 0 and then out EAX or out 0 EAX, that should take the value from the input of port 0 to the output of port 0, and it should send it to the screen. And since I wired it to 60,000, or since I wired port 0 to 60,000, it should send 60,000 to this screen. And yeah, there we go. What else should I probably explain how to do? I could explain how to do loops and things. Nah, I'll wait. That'll be a separate video. That'll be a separate video of me screwing around trying to actually show you how to do things. What else is there? Well, I showed you, that's the whole purpose. I showed you how to do that. I think that's it, really. This is so bad. I want to just keep this kind of short. Yeah, I think that's really it for right now. Yeah. Thanks for watching, I guess. Let me know if you want more of this. If you want me to go into more actual depth and see like how to genuinely use this thing, because you can create some crazy stuff. Like you can create games with it. You can create like computers with it. As I've shown off previously, my computer's terrible though. It's improved since you've last seen it, like, but it's still bad. But yeah, I don't even know what I'm saying anymore. That's it for now. Go away. That's it. That's it for now. So long.